So Tintin can't believe his eyes, because in front of him on the bench are two masterpieces of French instrumentation technology, both by the company Metrix, and this would be my first scope and my first multimeter. That's what I had as a kid when I was discovering electronics. And the scope was actually a gift from my neighbor, who was, I think, an electronics engineer in the army and had that old scope lying around. It's a tube instrument. And it served me very well. I just brought it back from my parents, so I want to get it working again. And the other one, also from Metrix, is the Metrix 462 multimeter, and that one is already all beautiful and repaired. It all works fine, thank you very much. But the same cannot be said for the scope, which doesn't even turn on. Hello and welcome back. These beauties from the 1950s must be pretty rare on this side of the pond. They were made by the French company Metrix, which had made a name for itself in the early days of radio and electronics, located in the beautiful town of Annecy near the French Alps, where they still are. Their 462 multimeter, which was also my first multimeter as a child, was a top hit, very popular among hobbyists and professionals. They also made this quirky scope which had its tube mounted on a pivot. It's like the Citroën of oscilloscopes. This is called the Model 217, but I could not find any reference nor documentation on it. It may have been a custom-made instrument for the military. I remember it as the most awesome thing I had ever had. It literally altered the course of my 12-year-old life as I started my discovery of electronics with it. In retrospect, it's a beautiful but embarrassingly basic scope, and it just proves that you don't need much to get started. I'm quite emotionally attached to it, and I can't wait to see if it is still as awesome as I remember it. So if you look at it, it's a very basic scope. Just one channel, gain, it's not even graduated. Cadrage is position. I think it goes at most a few tens or hundreds of kilohertz. It's just sort of synchronized on your signal, more or less. You can also use that in XY mode. That's basically all there is to it. 110 volts, 220, 50 and 60 hertz, and I'm not sure what those are. So last time I tried it, it didn't even power up, so let's open it up and see what's inside. I wouldn't have dared to open it up as a child, so this will be my first look inside. As I was reunited with it, all the memories started flooding back. The half-molten screw, yes, that was me and a 220 volts mains wire. The instrument survived that, the screw not so much. The on-off light that showed half red, half yellow and bothered me to no end. I spent endless hours learning electronics with this instrument. No adult help. Just the two of us in the attic, a few books, a pile of recuperation components, and a rusty-looking soldering iron that burned me a few times. This is where the molten screw goes, by the way. My accidental welding experiment got the chassis too, apparently. So many metric screws in the front, but it just pulls out. There were some screws at the bottom, but they broke in transport. So I have to replace those because it's so heavy. Alright. The beast is coming out. And voila! That actually looks very simple inside. It's just a very few tubes. So that's not a Tektronix or an HP scope. It's more like the Russian philosophy. What can you do with only 3 tubes that's rugged and will survive the war? And of course, like all tube equipment, it weighs a ton. 2 more tubes here, and there is in a high voltage rectifier hiding near the neck of the tube. You have to be pretty careful. Yeah, you can see it just over here behind the green resistor. It was fairly clean, but I cleaned it up before, so now it's all mostly cleaned up. I suspect the caps will have to be all changed. I reviewed all my 300 episodes of Mr. Carlson. Tested a few, some were good, some were half good. I tested some of the paper and wax caps, and they were all slightly leaky. And I tested the resistors, and the lower values were fine, the higher values had all drifted. And while I was testing things, I found that one of the resistors was a complete open, so this one is gonzo. There's also quite a few of those black guys peppered around. They are all about 0.3 microfarads. Also, there's no value written on it, so I had to measure them. And you might have wondered what are those big things, but they are just mechanical linkage, flexible mechanical linkage to the pots at the back. Some oil caps over here. Unless they leak, they usually age well, and we'll leave them alone if we can. But before we start blindly replacing caps and resistors, since I could not find any documentation on the scope, let's spend a bit of time reverse engineering it. It's only 6 tubes, not one of the monster HPs or techs with hundreds of tubes in them, so it should not be too hard. This is the 2 bottom boards and this board. But I should have the power supply in there. I suppose it's over here. And this is the back and bottom board of the horizontal amplifier and time base. So this is the board over here and this board over there. Okay, I think I got the high voltage part of the thing. I discovered though that there was a rework. That resistor here is replacing the one that's hidden underneath that's supposed to come out. So this wire, blue wire, was moved from here to here and replaced a 1 megohm resistor with a 910K resistor that is in the vertical position path. They lowered it for some reason, so either that resistor died or something happened, but it shouldn't float in. You shouldn't have the high voltage float in mid-air like this, so that's not too good. Alright, so here are the results of the doodling efforts. That's the main board underneath, the sideboard on the horizontal side, the back with all the high voltage stuff. That's the front contactor, that's the one over here. I identified the CRT tube as a Philips DG10-6. It has 11 pins at the back. I thought I counted wrong. It all matches up, it's the correct length, it's the right pins. Other Metrix scope for which we have the schematics use Philips tubes, so it's very likely I identified it correctly, which is good because if ours is dead from the transport, then we can find replacements for it. This is the same bowl of noodles but entangled, and it reveals the power supply. It's unregulated. It's just a double diode, one big cap. The second thing that I thought was a transformer is just an inductor and a cap filter, so it's just straight filtering to the V plus. And the only weird thing is that there are some resistors on the return on the ground, and I think that's the regulation actually. All the filaments are in parallel and in parallel with the on lamp. And I checked the on lamp, it's good, so I really wonder why it didn't turn on when I tried it. The high voltage is off a high voltage coil. There's a little high voltage diode riding at the top, and same thing, it just goes into resistors and it's filtered by one of the big oil caps. And then there's a whole complicated ladder down to B plus. First you get the VNelt, 100 volts or so. After that you get the cathode, the focus, maybe 400 volts after that. The position of the two plates, horizontal and vertical. And then you get the H amp and the V amp that are capacitively coupled. So that's another thing I learned, is that this thing is so simple. It's only AC coupled. There's no post acceleration either. So this runs out of minus 2 kilovolts. And I don't know what that is, a few hundred volts, I suppose. The vertical amplifier is somewhat unremarkable. It's 2 pentodes. The other thing that surprised me is that there's very little feedback, a little bit on that stage, none over here. So it's running full bore. So it goes to 2 stages of amplification straight out to the plates. And the time base is that pentode circuit, which was really very bizarre. And I had to look it up. It is called a transitron Miller oscillator. I found it in this book, and this must be a trick circuit from television where they do things that you would require 3 tubes to do it, and they do it with just 1 tube. It uses negative resistance between grid 2 and grid 3 of the pentode. The charging is through this first bank of capacitors through the B plus. It charges that cap, and then what resets it is this non-linearity here between the 2 grids, and they have another cap that does that, so the 2 sides are kind of in sync, and it goes to another amplifier. There is a blanking pulse that's extracted, goes back to the VNelt, so all the outputs go through the back where we had the jumper board, the VNelt that you can disconnect. So over here is the trigger, comes from the vertical amp, and then you can disconnect it for external triggering. It just goes into grid 3 that triggers it, sort of, kind of. I remember it didn't work very well. So I think we understand pretty much how that thing works. And after a recap, if it doesn't come back up, we should be able to debug it pretty well. By the way, it's been a real pain to find the actual components with the right voltage rating. They hardly make those anymore. So let's check if it was worth changing the caps. That's 12 nanofarads. And you look at here and see if it opens up. Should be around here, if I'm not mistaken. I see nothing. That's probably because it is leaky. If I do leakage 250 volts, boo, leaky. Compare that to the new one. not leaky, stays open. And then I probably can measure its capacitance. There it is. That's 0.1. This guy was definitely no good, paper cap. Let's try the 0.3. It should be on the same scale. Yeah, this one still measures. Is it leaky though? It's gonna get there eventually. Yeah, this one is it's a little lazy. Let's compare it to the replacement one. Alright. Again, this one opens up a lot faster, so definitely the other one was starting to leak. Now let's measure the electrolytics using the Heath kit, and that's supposed to be 100 microfarads. He measures more like 200, no, 150. In leakage, I cannot even measure the modern one. Also look like this, so I can't tell. So this one seems to have retained its capacitance. We'll check it on the HP. And this one is 16 microfarads. Over here. Yeah, still measure 16. So at least they are not completely dead as far as capacitance is concerned. This is surprisingly good. Let's see if the HP agrees. Yeah, 16 micro measures 20. Serial resistance 1.15. That's not bad. 100 micro measures 0.2 milliohms of serial resistance, and 150. So they are not as bad as a 1990 capacitor would be. Okay, on this side we have a whole bunch of paper caps. These are for the horizontal sweep. That's B+. Alright. So over here we have a bit of an issue. This is the center tap of the transformer. Those two wires and the capacitor, they're all supposed to get together. And the capacitor was held in place before by the bracket. I think I'll put one of the standoffs here. It's a little insulated standoff. Okay, I think that will work. Okay, so 100K. Yeah, I wonder how far off it was. It is 112K compared to the new one, which is 100K. So yeah, still within spec, We are overdoing it. Okay. Over here has drifted a bit high, 514. Do I want to clean that up? Because that shouldn't be like this, right? We'll see if we run into problems first. Alright, using patience and cunning, I was able to replace all my caps, and this one and the one that was buried there. I also managed to change the high value resistors, including the one that was embedded back there. And last but not least, this fellow, the one that was measuring infinite in circuit. I also changed some resistances on the boards, but not all. I changed the high value resistors, like this one, 100K, but I left anything below 100K. So that ended up being quite a bit of components. Here are all the caps. The electrolytics are pretty good, actually. But also the resistors. This 100K is 112K. Other 100K, 117K. Ooh, almost out of spec for a 20% resistor. This one, 111K. So they're all in spec, all high. Let's look at the 470K. That was the one that was across the high voltage diode. It was so hard to access, I had to cut it. Ooh, that's 507K. So that one is out of spec. What about this guy? 512, also high. 390K. 433, so that one is completely off spec. 4.7 meg. And surprise, that one is now 6.1 meg. The higher value ones are completely out of spec. That's the 1.5 meg that I thought was measuring open. Yep, it's still an open. See, it doesn't look original either, so I think that's been a replacement. And if you look at where it came from in the machine, between the focus and the horizontal position pot, that's also where they replaced this resistor in the horizontal position. So I'm wondering if the resistor was failing and they compensated by putting this one. Hopefully we'll be able to figure that out if we get this thing to work and get rid of this bad repair and put the resistor where it belongs. Okay, time to turn on the beast. Should be off. Okay, I shouldn't really need the variac, but just as a precaution. I don't see the light coming on. So usual warning here, this has lethal 2 kilovolt voltages in it, with caps that will keep it around way after it's unplugged. It's not a repair for a novice. Don't go and start imitating me unless you have experience dealing with high voltage circuits. No. Okay, I don't even see the light coming on here. So which means we would not have filament not filamenting. Okay, which is what I had before. Okay, so let's first check if we have filament voltage. Yeah, we do. Does it go to 6.3? It does. Okay. So how come I don't see my light? Dude in the middle. Oh, guys, I see something. So let me try it back. I'll put it over here. 6.3 volts. And I thought I had something for a second over here. Yeah, I do. It moved this direction. Goes down. Okay. My pot here is very scratchy. Okay. One bad pot. This works. Okay. Right, we have a trace. Okay. I guess we put the signal into the thing. So my bulb is bad? Oh, it's not making contact. Let's write the thing up. It appears to be the bulb holder. So I have connectivity here, but not through the center at all. Check that the bulb is fine. I took the bulb out here and it's good, so it's not the bulb. What is it? Okay, I know what happened. There was that in the socket, which I believe is the cover for the light, is what gives color to the light. It fell into the socket for some reason, so I have to put it back in. Still almost. Oh, it's Metrix. What an idiot. The Metrix is Metrix. Yes. We've proven it right here. Alright. Goes in here somewhere. It does. Right. And that gives the color. Let's see if that works any better. There you go. That's all there was to it. Okay, so that's fold number 1. So fold number 2 was my potentiometer being bad. The thing being full of charged caps. I should use gloves to turn it around. Okay. Here we go. And is this spot here. I might have to do a net color on it and take it out of the machine. Let's see if we can see any signal first. All right, dangerous beast. Erp. Okay, let's give it a try. Give it a 1 kilohertz here on the right thing, and now it turns on. Oh, the little indicator moved out, and we have a trace, which is, wow, it moves all over the place, which is bizarre because I replaced the caps, so I wouldn't expect it to do that. Okay, oh, okay, we have something. Oh. What is it? Is it the pot that's bad? No. Okay, so that works. Why is it wandering all over the place? Because they... So I would suspect that's a bad cap, but I changed all the caps. So it sort of kind of triggers. Oh, look at that. Why would that be the case? So I would expect that to happen if there was some leakage between the last stage and the plates, but
I'd look at the power supply for the vertical amplifier. Just see if it's stable.
yeah. Might be the oil caps, but you look at that, it's doing the right thing, right? That's through the oil caps. Okay. Let's see what I have in my high voltage capacitor store. So we made that little thing to discharge the caps. Okay, that seems to be fine. Yeah, there are those two caps. So that's the only thing that's capacitive and high voltage source. Yeah, should be fine. This just bothers me to have this flying high voltage thing. Okay. That's the modification undone. Alright, so try again with modification undone. It's coming. And it should only affect up and down. It's just fine. Yeah, it's centered. If I put that at 0, is it moving? Yes, it is. So then it has to be the high voltage. The position of the beam is only controlled by the high voltage. So I would know if it's moved in Y also, in X also. Yeah, it moves both ways.
At the same time?
Mm-hmm. So I think it is high voltage instability, which means I need to replace the two caps, which are 2 kilovolt 500. I need to replace the oil caps. So it turns out I have almost the right thing. 0.33 at 2 kilovolt. I would really need 0.5 at 3 kilovolt, but for a trial that would do. And I'll just do a temporary bad job. So I have discharged the caps. Confirm on camera that they are discharged. The joys of high voltage tube circuits. But this is even worse. This is CRT circuits. They are very joyful. All right.
There you go.
All right.
Got it.
Okay. So this is our janky 2 kilovolt modification. But it's an experiment to just know if it's the cap or if it's something else. I think I should be fine. And it wasn't the caps, I see. Or was it?
Well, let it warm up.
It hasn't changed the brightness at all. Still moving around a bit. Looks
A whole lot better.
It looks more stable.
Yep.
So I need to order two. Well, is it still moving or not? Not as widely as before.
Well, there might be other causes, but that certainly looks like was the dominant one.
Yeah, and now we'll have non-leaky caps, so we have to be really careful. Oh, no. See, it's still moved down. Oh no, it's still moving around, so that's not it. Is it microphonic? Do you see it?
Yep. I'm guessing you don't have a multimeter that can tolerate 2 kV.
I do. I have a probe.
Ah,
But yeah, last time I checked the high voltage on the scope, it arced and destroyed the whole thing. I had a hard time to recover from it. So if I can avoid measuring it, less chances for arcs. All right, so we decided we'll first clean the pot, or I decided we'll first clean the pot, do our go full at color on it, as I call it. Except it doesn't want to come out. See if the source is the source of the instability, but I don't think it is. I think there's something else. There you go, got it. Yeah. We have the crusty pot. Very, very crusty. Oh, can we open this one? Oh, this is not a standard construction at all. This is a silly European pot. Look at it, the whole entire top lip.
Oh, it's not just little tabs.
No.
That.
It's, can you see? It's,
yeah, that's going to be real tough to open up.
the entire lip is turned.
Yeah.
Oh,
and
man.
there's no place to squirt cleaning goop in there either.
So it's a very unhappy pot, and it measures 770K, but it's supposed to be 500K, so it's gone bad too on the base resistance.
Yeah.
It's not worth dealing with that one. I just need to buy a
Yeah, I
new
don't
one.
think you can open this without destroying it.
Okay, so we have removed the pot and we have put fixed resistors, and it still does the same dance. So not the input pot, not the capacitors, the high voltage capacitors. It's something else. So we are still trying to chase down the instability, and since it's annoying to measure the 2 kilovolts, we instead measure the focusing voltage, which is related to the high voltage. So we're on the focusing grid, and the Metrix tells us it's 840 volts, and it's not moving even though the trace is unstable. So what will happen is that the gain will get lower, and then it will reset. But anyhow, the gist is that the high voltage supply seems to be stable, so that shouldn't be our problem. So right now we are on that grid. That seems to be stable, so let's go down to the other one, which is B+. By the way, the two are tied together, which is a little bit of a problem, because one might influence the other. So to B+ we go. Let's go. Give it a shot. Let's see what happens.
325.
25, and then what I've observed is that it grows to 340 something, and then while it does that, the gain diminishes. Something happens, it drops down to 320. There is some instability that reflects in B+, which doesn't tell us if B+ is causing it, because B+ is unregulated, so it could be that the vertical amplifier is big unstable and causes drawing more or less current. Yeah, there you go, it's starting to do it. Tough, it did it. But what causes that?
So I'm just wondering if these capacitors maybe aren't tolerating the voltage as expected.
We could test voltage. It should be completely stable.
Right. So can we measure on the positive terminal of either that cap or that cap?
We sure can.
Moments later.
So we decided to probe across those caps here, which I have changed. And I noticed they were getting hot. And so we measured against the one that's not there anymore. What did I do with the cap? It's over here. We removed it because it was getting hot. No change. Checked that it was the right voltage. Yes, 450 volts. He had like 100 voltage or 120 across it. Then we could see the voltage rising and then dropping all of a sudden when we had a move on the screen. Then I said, oh, the cap shouldn't do that. And I started to test the resistor next to it. And this resistor, which should be 20K, is measuring 800K. So something happened. The other resistors are fine. And of course, this is the only resistor I didn't test. So we have a bad 20K. Is that the whole story? I think that could be it. That could be it.
It looks like it's maybe a 1 watt resistor.
Yeah. So turns out I had a 25k. That's the right wattage. So it's not quite exactly perfect, but should be good enough. So we put the capacitor back in. We're measuring the cap voltage on our trusty Metrix. Okay, it's on. Woo! Alright, so that goes at much higher voltage now.
It's about...
Wait, and I'm not seeing anything on the trace. Why is that? That's no good. Hold on a second. Did I do something
Are
wrong?
those in the right way round? Ah, you might want to put that tube back in.
Ah! That will explain it. We forgot the tube. Well, which is another experiment we could have made, right? Remove the tube and see if the instability goes away. Okay, we now have a tube, and let's see if that works better. I want it very much to be that resistor, because if not, I cannot explain. Alright.
That's about 160 volts.
Okay. And I can see it's more stable already. Okay. Except
The triggering.
yeah, well, the trigger was never good.
Yeah.
Okay, I think we got it.
I wonder if those caps still get hot.
Hopefully they won't get the. So what was happening is that the poor cap got the AC, that AC, right, at a few 50 volts, and it went right through it. That's the only way to the current had to go to ground, and then it got hot. So now that should be much better. Okay, yeah, we fixed it. Wow, that was unexpected. And I measured all the resistors but that one. Yeah, so it's not doing what it used to do.
Yeah, that's
which we didn't film, sorry, but when we saw that voltage doing weird things and the cap getting hot, we closed shop pretty quick.
Yeah.
Well, I wasn't expected actually that the fault was
well,
a resistor in an amp.
had to be something.
Right. I think the tube went into a negative resistance. That's how this works. It works with the negative resistance with the grid number 2. And I think something happens. The cap charged, and then it went into negative resistance, and then the electrons went there from the tube, and then it started again.
Yep.
Okay, it's fixed. Alright, so other pot, other resistor. I am tempted to put back the original capacitors because at the back I think they were fine.
Right.
Alright, it's back on its original high voltage caps at the back, and then temporarily I put the bad pot in where I'll get another one, which is enough to get us a scope that is now stable. So the damage was actually, apart from the bad caps, was 2 bad resistors. I had one 1.5 meg that was completely open in the back, and the 20k, which led to this weird failure where the cap was charging and discharging through the tube. But not bad.
Pretty impressive.
Yeah, and this is 30 millivolts, by the way. This is fairly low. This is good sensitivity. And let's see. 1 kilohertz, 100 kilohertz. Oh yeah. How we'll do in square wave? Probably not good. Ooh, that's the square wave. So it's definitely 100 kilohertz with being very generous here. It's a 50. It's a 10 kilohertz scope. My goodness. It's as bad as I remember it. Okay, 10 kilohertz. Okay. It's Philip. It's a 10 kilohertz scope. I was exaggerating.
Yeah.
Right.
So good for audio.
Yeah, or if you want to see signals in in the IF that are sinusoidal, but okay, well the importance of that scope is that it taught me enough electronics that I could repair it 50 years later. It put me on the right path. Right. That's the importance of it.
We bring in a second sine wave?
Oh, you want to do Lissajous curve?
Yeah.
All right. Yes.
There we go.
And then you put it on H. That I was really good at. Yeah. That I really enjoyed it for that. 1 kilohertz. Oh, I am. Dang, there we go. No, it's perfectly stable. Man, the one resistor just threw the whole thing on its side. There you go, I'm at 1 kilohertz in something. You want 3?
Yeah.
There you go.
So other than that it's rolling vertically rather
Oh, because I made it on purpose.
I can fix that. Obviously I can't fix it.
What do you want to do?
I swapped around because I wanted to...
Oh, so... yes, I can fix that for you.
Actually, it's a gain issue?
Yes. It's because the H-axis is not very sensitive, so first you have to go wee.
Oh, okay.
And then I have to go give you more juice. Are you happier?
I am, because I grew up in Australia, and that rotating Resistor figure was ABC TV's logo.
Oh, really? Well, I had to look that one up, but indeed, here is the early Australian TV logo from the days of black and white TV. They don't make them like they used to. What was that series where they had an oscilloscope curve say do not adjust your TV? It's a sci-fi series.
Yeah, that was the Outer Limits.
Yeah, that was awesome.
1 week later.
So I eventually replaced all the resistors. These over here, this one there. So this is all the replaced stuff. But if you look at where the actually failed components that would have prevented the thing to work, they are only 4 or 4.5. The 20K that actually out of circuit it tests at 1 megohm. The 1.5 meg that tests infinite. The capacitor that is no more a capacitor, but you can tell by just looking at it. And then honorable mention for the 4.7 meg that tests 6 and 500K pot that tests 700. And probably would have worked with those two. So if the minimum that would have repaired it, those 3 would probably be the minimum that would have repaired it. Anyhow, now we have prevented future problems and probably made it better. And it should be revived. So what I want to do next is see if we can do the oscilloscope music on it. So yeah, my first ever scope is back, in no small part because of all it taught me. And it gave both Philip and I a good trip down memory lane. It worked great for oscilloscope music, I'll probably post that in a companion video. But you might wonder what caused that good looking 20 kilo ohm resistor to go to 1 megohm. I wondered too, so a deeper look is coming up in another companion video, and the results surprised us a bit. So see you in the next episode.